Hi, thanks for watching this video. This video provides you with a clear solution to AtCoder Beginner Contest 306F. I have written the correct code and it's in the description of this video, so if you want to see it before listening to me, please check it first. Anyway, let's start with the problem settings. We have n sets represented as AI, and each set AI has exactly m elements. The number of sets n is at most 10 to the fourth. The number of elements in each set m is at most 10 squared. And any two sets I and aj are mutually exclusive, which means all the nm elements are distinct. We define the function f for two sets A and B. The value is the sum of sorted indexes in the union of A and B whose elements belong to A. For example, considering f of A1 and A2, the union of the two sets is as follows. Number them in ascending order starting from 1. A&'s elements are 1, 3, and 5. So the value of the function f is 1 plus 3 plus 4, which equals 8. Our problem is to calculate this expression, that is, adding up the value of the function for all pairs of sets A. First, let's calculate the function directly. Here is a step-by-step process for finding the value of f for A1 and A2. Firstly, merge these two sets and get the union with a size of 2m. Since we need to know the sorted indexes, we sort the union set. Finally, we add up the indexes of A1 and obtain the answer 8. The bottleneck of this process is sorting, which takes 2m log 2m time. Now, how many times do we repeat this process? The number of pairs is n chose 2, so we repeat it approximately n squared times. Therefore, the total time consumption exceeds the time limit because it is about 10 to the 7th. Our first attempt has failed, but we can improve it. Let's further analyze the function with some examples. First, if the union of A1 and A2 looks like this, then the value of the function is simply 1 plus 2 plus 3. This is because all the elements in A2 are greater than the elements in A1. Secondly, if the union looks like this, the answer is 1 plus 3 plus 4. I split the expression into two parts, 1 plus 2 plus 3 and plus 2. Why is the second value greater than the first value by 2? The answer is that element 2 in A2 is greater than the two elements 3 and 5 in A1. If some elements from A2 are inserted on the left side of a specific element in A1, then the index of that A1 element becomes larger by the number of those A2 elements. If you don't understand this concept, let's examine the third example before moving on to the next slide. Generalizing the previous idea, we can express the function as follows. The first part on the right side is the base value of the function, independent of the index of set AI, and easy to compute. The second part is still complicated, and we need to simplify it further. Now, let's consider adding up the functions from A1 to A3. We can combine the last two terms because they both use A3 elements for comparison. This implies that we can reduce the total number of steps required for calculation. In conclusion, let's get back to the problem. Our target expression can be calculated as follows. The first term represents the base value of the function multiplied by the number of functions. We immediately compute it as follows. The second term indicates that for each element in each set, we add the number of elements greater than that element. If we know a first method to compute the content of this sigma, the number of steps for the sigma term is about 10 to the 6, so we can calculate everything within the time limit. The final task is figuring out how to compute the content. Finally, I will explain the algorithm computing the second term with this example. First, prepare an initialized list with a size of nm. Insert the elements from A1. Then, calculate the cumulative sum for each element in A2 using the list. This operation counts the number of A1 elements greater than the corresponding A2 elements. Next, insert the elements from A2. After that, calculate the cumulative sum for each element in A3. This counts the number of A1 plus A2 elements greater than the corresponding A3 elements. Repeat this process if you have more sets. Through this algorithm, the insertion of elements occurs only nm times, and calculating the cumulative sum occurs nm times as well. If you use the well-known data structure segment 3 to calculate the cumulative sum, it takes only logarithmic time. I won't explain segment 3 here, but anyway, the total time consumption is about 10 to the 7th, which is acceptable. We have successfully solved this problem. I have finished the explanation. If you have any questions about the problem or request to solve other ABC problems, feel free to comment. Thanks for watching.